Swayam Prabha. Digital India. Educated India.
We will cover the second part of activity-based models. The different concepts that we will cover in this particular lecture will be the background. We will start with the background, then we will look into the activity-based model components, the daily model, and we looked into the long-term model or long-term choice models in the earlier lecture. Then we will look into daily activity patterns and activity scheduling, time of day in activity-based models, scheduling of tours. Then we will look into albatross, which is one of the most famous activity-based model or most popular. Then we will look into the data requirements for activity-based model. So, just giving you a brief about reminder about what we have discussed earlier. We have talked about activity-based model, which is part of our overall land use transportation modeling framework. And within that activity-based model, we can say that land use and economic development part, all these things give an input to the activity pattern, and this part is an activity pattern, activity-based model. Sorry. So, this part is that household and individual activity pattern part, where we have got lifestyle and mobility decisions. These are the long term choices which actually influences our activity and travel schedule for our individual daily travel pattern. And then finally, we also need to do implementation and rescheduling of this pattern. So, we start with a pattern, but based on certain constraint and based on certain activities, based on joint activities, this pattern could be also rescheduled. And finally, once we are fixed that particular scheduling, then we can give it as an input to the transportation system performance process. That means where we load it into the links, we load the tours and the trips that are designed out of this activity pattern into the transportation network, and that can come back as a feedback. So, this is the part which we are concerned about when we are developing activity based model. The rest is part of the land use transportation framework. Now, just to another small reminder from last lecture, that when we are at home, we can go for a trip to work and then another trip to shopping and then another trip to home. So, this together becomes one tour. So, home to work and back to home via a stop which is shopping. This is a secondary activity. This together makes one tour. Now, from office I go to a meeting and then again come back to office. So, this becomes a work based route. And finally, we have got trip 6 and trip 7, that is from home I go to dining and then again come back to home. This becomes my second home based tour. So, total I have got 3 tours that I need to schedule in a single day. So, this is activities and trips in a working day for a individual. So, that is what is the structure that we need to arrive at. So, we start with lifestyle and mobility decisions, we schedule a person's activities and then we implement and reschedule those activities, and eventually we have to come out with this particular structure of tours and trips which we will use to determine which we will use to load the transportation network. That means the trips, each trip will have its mode choice, we will also have destination choice, the time of the day, those would be loaded into the transportation network. So, in activity based model components, when we talk about the daily model, we integrate time of the day and different temporal constraints considering full day. So, that means we have to consider the trade-offs considering a 24-hour limit for a day. That means we have a 24-hour limit. Within that, we have to sequence our activities, and then we have to consider that at different times of the day, what kind of activities take place. So, we need to know the activity sequences and duration. That means each activity, how long it takes, and what is its sequence, which has to be done first, which has to be done second, and so on. Then that is what priorities of activities, which are main activities, which are secondary activities, and so on. Then based on this, we need to determine what kind of tours could be formed out of this activity. Then when we form those tours, then we take feedback from the travel information like network availability, car availability, and so on. So there is travel time feedback. So all these feedbacks actually leads to change in the tour, maybe. Some it may change, it may not change, and then we reschedule our activities further, and finally we revise our tours, and eventually after a certain number of iterations we may come to a stable pattern, and then we can have the full day level of activities. Then we can determine the tours that is there in that particular set of activities, and within each tour what are the different trips. So first we decide on the activity pattern of travel, and then for this activity pattern, how many tours are required to support this activity pattern, that is being determined. So how do I classify activities? Activities could be classified like out of home activities or at home activities. So this is the first kind. So we can do certain activities at home, certain activities at out of home. Now when I talk about out of home activities, then actually this kind of classification is not fixed classification. Different authors have done, different modelers have used different classifications as per their model conveniences, but these are the standard way we can actually classify the different activities. So out of home activities could be classified as mandatory activities, maintenance activities, and discretionary activities. Now mandatory activities are work or business, that means every day a person goes to work, that is mandatory, or for a child it is for school, college, or university. So these are the two mandatory activities that a person needs to do. That means they have got their own fixed time schedules that has to be there, that has to be adhered to. Then there are maintenance activities. What maintenance activities? Like these are also important activities, like escorting passengers, like escorting my kid to school. So kid has to go to school, so somebody has to escort. So I am escorting him or her. So that means it's an important tour. It's a tour which has to be done, but it's a maintenance tour. So it's I am supporting somebody else in the family, or I am supporting the household. Then shopping. Shopping is the activity required for the household. So either the wife has to do it, or the husband has to do it, or both has to do it. So that means it's again a maintenance activity. Then personal business, that means I can go for medical or some other checks and all, which is also very, very mandatory. So then there are discretionary activities like eating out, visiting relatives and friends, social and recreational activities. So as you can understand, these are second priority activities. That means if these things are done, that means my mandatory thing is taken care of, then there are secondary, my activities are taken care of, and then I have got my discretionary activities. That means I may go if I have got time, I have got enough time, I have got other constraints or not issues, then I can also go for this kind of categories. So this is the thought process of the when we do this kind of modeling. But somebody can think in a different way. Somebody may think that all these things has to be done in a joint fashion. That means maybe some maintenance I can trade off with some discretionary activities. Could happen. So I may think that, well, okay, I will delay my shopping to next day. Let's do some amount of recreational today. So this kind of trade-offs can also happen. But this is just to make sure that the basic things are met, or most of the people actually follow this kind of rules. So this kind of rules are actually created at the beginning. So there are some activities which are, once I decide on maintenance, like I need to do this activity, that means this is a joint activity with myself and my kid, or it could be a joint activity. Shopping could be a joint activity with myself and my wife. So that means it could be an individual intra-household interaction could be an individual level activity, or it could be a joint activity, or it could be allocated to me as well. That means somebody is allocated a certain task, right? So these are inter-household interactions that also needs to be considered. And then we have to give priority within a tour. That means when I am scheduling a tour is I have to go to a certain activity. Suppose I am going to work. So from work I am coming back to home as well. Now in between I want to do some discretionary activity, which is, or maybe a maintenance activity like shopping. So within that tour that we form, there has to be a primary activity destination versus a secondary activity or shopping. There may be a secondary activity, there may not be a secondary activity. That is not the issue. The issue is there, if there is a secondary activity, that means it is priority 2. Only if this is met, the time schedules are met, the location is okay, then only I can decide on the second order activity. So I don't decide them together, that to maximize their total utility. So I will make it one at a time, so in sequence. So that is why there is a priority as well. So once I have understood the different types of activities that are possible, I need to also develop the individual daily activity pattern, or IDAP. So that means it includes activities and travel which are defined by tours of particular purposes, or we can say activities as well. So for each activity or purpose we can define different travel and tours, and that actually this is a broad purpose. Within activities there could be sub activities as well. So we actually include both activities and travel as per the for that particular person. And then we need to find the different dimensions of this activity pattern are the pattern type, like generation of tours by purpose as per day, and travel behavior of individual, like what are based on the long term choices and all. Where do we wants to go to, when do we wants to go to work, where means will he go to work in the office or will he stay at home, all these kind of decisions could be taken. Then we decide on the tour sets where we combine primary activity with and primary destination, and with secondary activities like stops within tours and so on. So which are conducted on the way to main destination. So this actually gives us the overall individual daily activity pattern. And then there are some coordinated daily activity patterns. So this is same as what we were discussing earlier. Only thing is, from household understanding what are the trips that are there, that has to be mandatory activities and all, which then we have to put it to an individual's perspective, that what a particular individual has to do, what tour he has to make, and so on. And then coordinated daily activity pattern is again the same thing. It depends on the household pattern, joint occurrence of IDAPs for members. That means both the IDAPs as for two individual members has to be compared, and one of segment of that IDAP would be assigned to a joint activity if both of them are free in that particular segment. So that is where the household pattern comes in. So new interactions between IDAPs. So we have to also check the interactions between two persons' individual activity pattern and see where are the dependencies, where are the constraints, and so on. So this sounds a little tough, it sounds a little complicated, but actually we can always do it much simply as well. So I will show you that. So let's find suppose a person, when I'm trying to decide on what is his daily activity pattern. So what are the choices he has got? Ultimately it's a question of what he chooses to do. So a person, let us just forget this side of the table, like on the right side of the table, just we look into the second column. So there are some mandatory activities, there are some non-mandatory activities. So what are the mandatory activities? Work, one work, two work. Two work means I go to two places to work. So I've got two shifts to work, or maybe two offices to work. Or it could be one work plus one school. That means I go to school as well as I do part-time work. Or it could be just going to school or university. So this is my mandatory work. Non-mandatory work could be there could be many non-mandatory work. So but one option is we can stay at home as well, and we can do just non-mandatory work. That means nothing else. We don't do any mandatory work, only non-mandatory work, right? So that also could be there. What could be the non-mandatory tours? Non-mandatory tours could be I can have 0 non-mandatory tour. This is one option. I can have one escort, shop or maintenance activity tour. I can have one eating, visit or discretion tour, or one maintenance and one discretion tour. So I can have different combinations of this non-mandatory activity. So if I do a tour which includes a mandatory tour as well as a non-mandatory tour activity, in that sense I will have how many alternatives? So in the first we were having like around over in the non-mandatory part we are having 1, 2, 3, 4 activities, and over here how many? 1, 2, 3, 4 and 5. So 5 into 4, 20 options of combinations of activities that we can do in a particular tour. So I can go to work and I can do eating, I can go to work and I can do maintenance, I can go to work when I can go to eating. I have not included all of them because there was not enough space in this particular table to fit in this page. So actually all these options are there for all these options. So we can have a combination of different options. So for a particular person or a household, based on his other lifestyle choices like car ownership, location of stay and so many other things, I will, and his economic background, based on my survey sample data, I will assign him a particular alternative for a particular day. Like a weekday, maybe I will assign something. In a non-weekday, I will assign some other tour or a tour, this main primary activity pattern. So this activity pattern is again, there are so many combinations that are possible for a particular person. So he is given one activity pattern based on his probability of doing that particular activity pattern. So this is how we assign an activity pattern to a particular person. So it's like the same thing. We have trip rates for different households. So we assign that so many people would be doing so many trips, and when we are doing discrete choice, we are having a probability wise that okay, one person will go to location 1, another person will go to location 2 and so on. This is exactly same thing. That means one person will do this activity, another person will do the other activity, but it has to be based on that context, based on his background, based on his socioeconomic characteristics and so on, which is the likely things whichever we can assign him one of those activities. And because we are doing it for the all individuals in the city using a simulated population, automatically the choices we will get eventual estimates would actually, when we aggregate them, we will get a combination of different activities by different individuals. So then once we have decided on what are the main activities, we also need to understand at what time of the day this activity would be performed. This leads to consistent scheduling of daily activity pattern, including trips and tours, and this helps in estimating congestion, level of service, etc. as well. So if I know that what time the trip is being taken, I can also decide on congestion, level of service, because if it is during peak hours or non-peak hours, accordingly those will have different impacts. So time of the day is very, very important, and it also helps us to schedule the activity pattern. So when one activity, it has got a particular time period, like work is for 5 hours or 9 hours. So when that activity is done, then only I have got free time. So that is the time when I will travel. So then I have got this travel choices, right? So if I have my work ends at 5 o'clock and then I have to return home by 7 o'clock. So I have option in between of 2 hours when I can do something else, where also I have to also travel. So you can see that within 5 to 7 there is 2 hours, which is equivalent to 120 minutes. So I can start any point of time. If I don't do any activity, I can take a trip any point of time within that 120 minutes. So I have got that choices, but this depends if I am doing every minute of the day, we are considering that. But if I had 30-minute intervals, then I have got only 4 options, right? So I can choose any one of them, those 4 options to start my trip. So that way, if I can do this break my entire choices using some temporal resolution, I can also either consider 30 to 60 minutes, or it could be 5 to 15 minutes, or it could be a continuous, that means every 1 minute. So every 1 minute, even though it's a discrete, we can consider it to be continuous, and then we can divide my decisions into that way. But you have to also understand, like this actually is also very challenging. I will explain that. ABM with continuous time scheduling, these are some of the models which have done this 1 minute time schedules. These are very difficult to apply. Why? The reason, if you can see this, like for example, I have got 24 hours in a day, right? So if I do 60-minute intervals, that means I can do only hourly divisions. That means my trip departure can happen, there are 24 chances to have a trip departure. Now, if I introduce a constraint like this is a trip for work, so that means it can only start at a certain time and end at a certain time. So, let us assume that it cannot start before 5 and it cannot start after 12. So, that means 12 to 5 people will sleep. So, that is a constraint. So, it can only start within any one of the 21 options which is beyond 5 to 12. So, 5 to 12 if I take, that means it can start at 5, it can also end at 12. So, in between we have got 21 options to choose from if it is hourly options, right. Now, this is for trip departure, but if I consider a tour, tour has got a start, it has got an end. So, if I determine the start and end time of a tour, then how many options? 24 if it is, if it is for the full day, 24 into 24 plus 1 divided by 2, because why this 24 plus 1 divided by 2? Because for every decision I take, the second decision is only conditional on the end is conditional on the first start time. So, if I start at maybe after 6 hours, then automatically my end time is also the time slots for end time also reduces. So, actually if I take average of that, my ending time is actually the options become half. So, that is why we have taken 24 into 20, because 24 plus 1, because we have got both edges we have to consider, both sides we have to consider, plus 1 divided by 2 to make it half. So, that means the ending options are half of the starting options. So, 24 into this, we get 300 options. So, we can have a tour which have got 300 alternatives for time of day. So, if I introduce some constraint, it reduces, like 5 AM to midnight constraint, it reduces to 48 to 40. But we can always use many other constraints, like a tour can only start at a certain time period and end at a certain time period. So, we will end up with much smaller constraint. We do not have to deal with, like if I go for 1 minute continuous departure, I end up with 103 10,37,520 options for to conduct a tour, including its start and end time. So, of course, this becomes impractical. So, this is where the constraints play a role, and the constraints can limit my number of choices, but even so there are a lot of choices when a person can start, and this is where probability comes in. Based on again decision rules and all, we can decide that okay, which is the most likely, and we can assign, we can based on the probability distribution from the sample survey, we can also use that using random numbers, we can randomly select certain start times and all, and that way also we can decide on when a tour can start. So, that is how we can do the models. We can attach time to a particular starting point of a tour. So, this two time of day model and this joint choice of departure time from home or arrival at work and arrival time back home or departure from work, this is, we can do a joint model of that. So, last time we were discussing, this is when we are discussing a joint, like a tour starts at departure starts now and ends now. So, this joint model actually have so many combinations that we were discussing, that time of the day. So, total duration including once we do that, we get certain things. We have like start time, end time of a tour. From that we can determine what is the total duration including activity and travel. So, this is my first thing that we are getting. So, we get the activity duration. Now, once we can also do it like every 30 minutes from 5 AM to 24 PM, as I was discussing, time rounded up to the nearest half hour. But at the end of the day, we can do it for each minute or 30 minutes, doesn't matter. So, we have a start and end time, and we also know the duration of that particular activity. Now, this concept is called the concept of time window. So, using this concept of time window, I can now schedule my tours for home based work. So, I have now fixed my schedule for my activity. This is overall, going to work and coming back from work. This is my activity, and then I am scheduling for my tours. So, first I will decide on what is my mandatory tour, which is work, and school tours are usually mandatory tours. So these are scheduled first. So I will first choose, this is my scheduled work. So it starts somewhere around 8 maybe, and then ends around 4 maybe, right? So this is my fixed time for work. And then next, I propose joint tours are scheduled in the remaining time window. So I have to go to shop with my somebody else. So I will also, maybe my wife's time of work is somewhere here. So she is free over at this location. I am free from this. So we schedule that, okay, we will both go for shopping in this particular zone. So this time is again taken up. So this is the next, joint tours are scheduled. And finally, I have a individual or non-mandatory tours which have to be scheduled. So which could be scheduled in between this, either work and shop in between, or it could be scheduled even after that. So there is no, so based on the available free slots, I will be able to schedule that. So this is the process how we schedule my activities within a particular time, within a day, and within a activity this time period. And then from there, to arrive at work at this particular time period, I need to start somewhere in between this. I can start over here and reach the office over here. I can start here, reach the office over here. So this, within this gap, suppose this is a 2-hour gap and I require only 1 hour to travel, then I have so many options to start and end. So that again depends on probability and the mode choice. So all these things, this is how we schedule our tours, and from tours we will get our trips. So additionally, looking at the time window constraint, it determines the time of additional tour and also its destination and mode choice. So we can schedule joint tours with household members participating in a tour should be able to avail the time window. This we just discussed. So we need to so this additional tours that we need to consider, we also need to look at their destination and mode choice. That means certain activities are not possible because of the choice of their destination and mode choice. So mode takes 2 hours and destination is at a certain distance or location, and to reach there we require 2 hours. So probably those alternatives will not be available to me to choose from. So this choice of a location to go for eating will probably depend on that available time that we have in hand, right? So how do we simulate this additional stops, like we go to a shop or we go to eat? So there could be different approaches. Again, this depends on the modeler, how he thinks of those processes. So what is the way he has assumed those processes to happen? So first, activity at primary destination, and then tour is built up in the outward direction. So first we determine the primary destination, and then once we fix that, then we build the tour in the outward direction. So that means what else can we do? What else can we do? In that way we can keep on adding till my time is over. Or once tour duration is fixed, that means we fix the overall duration like we did last time. Then within that we could organize it inwards. That means first we schedule work, and then we schedule shop, then we schedule eat accordingly. So it could be gradually building up, or it could be fixing the entire time period and then filling in the gaps. Both approaches are fine. So once we do this, once we have the schedules and all, along with this, we can jointly determine the destination choices of primary activities, which comes from maybe location choice models, and additional shops could be based on the available time periods and the available modes to reach those particular alternatives. What could be the additional stops where actually this person will go, that would be determined. And choice, and from this we can also have our choice of trip mode, conditional or tour mode, and also conditionals on other upstream choices. Upstream choices are destination, other upstream choices are the activity schedule, and so onwards. So as you can know, if we have 2 destinations, each 2 destinations will have tour modes. So we can have hierarchical logic structures over here as well. So this is the theory. I am explaining you the theory of this model. Practically, when we implement this model, it may be a simpler version of this, or it may be a complicated version of this. But there we have to, each different models that has been developed that has adopted different strategies, different processes. But these are the fundamental thinking or theory behind developing our activity-based model. So, some of the questions that we can ask are mandatory and non-mandatory tours generated in sequence or jointly? So, that means mandatory, and we can do it in sequence. One, first we decide on mandatory, then we decide on the non-mandatory, or do a person decides all of them together? So, this is a question. Each modeler can assume different strategies. All activities leads to tours, or major tours then secondary activities. So, either we decide on all the activities, then we decide on the tour, or we first decide on the tour, major tours means main activity, it's the tour related with that, and we based on the tour pattern and all the timings and all, we decide on the secondary activities. So, this sequence is also important. All tours jointly modeled considering substitution or separately. That means there could be substitution between two tours, like I can first go to office and then come back to home, then go for shopping, or I can go to shop in between. So, there could be substitution in between tours. So, are all tours jointly modeled or separately? Then household maintenance tours, individual or coordinated household patterns. This also could be looked at if it is individual or if it is a coordinated household pattern. We need to determine that. And are all IDAPs jointly decided along with other household members? So, do we individually decide on individual daily pattern and then we see the consistencies or see the constraints, or we jointly model them together? So, that means we jointly model them together means we maximize their overall utility. Which approach do we take? So, these are the questions that different people have answered in different ways. So, again these are for you to decide which one you will adopt, and that has to be probably looked into the sample data and also the local context and the culture, the way people do certain things, and based on that we have to decide. So, Albatross is the most famous of this computational choice process models, and this is very common. This is a popular model in activity based modeling, and Albatross comes from a learning based transportation oriented simulation system. So, it is learning based, so it depends on certain learning algorithms, and it was developed in Netherlands by Arendse and Timmermans. First computational process model of complete activity scheduling process. Then it's sequential, it does it in stages, it doesn't do it in jointly. It's a multi-stage activity scheduling process. Assumptions: individual use a computational process which tries to realize a daily goal for a particular activity space under certain constraints. So, we need to develop the overall activity pattern for a particular day and considering certain constraints. So, for each individual, a preliminary schedule is developed based on static and dynamic constraints. Certain constraints are considered. Then subsequent modification to resolve conflicts, because there are some constraints may come into play, some joint tours can happen. So, some modifications happen. Then modification during execution to deal with unexpected events, like change in feasible activity space or activity demand, like certain things change because of the travel feedback, certain things changes, then again some tours and all can be changed during the execution process. So, this model predicts which activities are conducted, when and where, for how long, with whom it is conducted, when, location choice, where, time of the day, how long is the activity period, this period, and with whom, is it a joint activity or not. So, these are the decisions that are taken, and what is the final transport mode required to support this kind of activities. So, what are the constraints that are considered? Institutional constraint, rules, laws and all. Situational constraint can be in one place and one time only, a particular individual. Household responsibilities towards the household members, like escort tours and all this. Time, duration of activities, like there are certain time that has to be there for a particular activity, and spatial temporal constraints. So, these are the different constraints that has been considered. A decision tree learning algorithm is used to model the heuristic choice. So, a decision tree algorithm is used, and within decision tree could be solved by many algorithms. So, here it's they have used the CHAID algorithm, which is chi-square automated interaction detector. This is the algorithm that they have used in Albatross. So, there could be many algorithms, like we will explain also some of this decision trees in the next lecture. So, classification of activities that has been used in the Albatross model are: work and school, these are fixed activities. Bring or get person goods or goods, medical visits, personal business, sleep and eat. So these are some fixed activities. Some flexible activities like daily shopping, service related activities, non-daily shopping, social activities, leisure activities like sports, concert. These are all flexible activities. So they have divided on fixed and flexible activities. So they have not made mandatory and in that order. So it depends from modular to modular, but the concept should be something on those lines. So this is how things have been decided. Like I have included in the reference some papers by Arenzi and Timmermans. You can study those in detail. But just to give you a brief idea, like this is first skeleton schedule is being prepared. Then we decide on the activities, and then we select if another activity is there or not, yes or no. Then with whom that activity is done, what is the duration of the activity, and then we add it to that. So when we have a skeleton framework of all the major activities and all, then what we do is we determine the we check on the other additional activities that are possible, like the flexible activities. And when we have done with both main activities and flexible activities, we can develop the trip chains, and that means we end up with schedules and tours. So we have both the schedule of the day and the tours that would be possible. So that would be created. And when we have schedules and tours, the next level of choice heuristics or decision heuristics comes like what would be the mode choice. If mode choice is there, then what would be the second mode choice, then which location. If it is yes or no, then the next location. So if one location fails, then the next location. Same goes for mode choice and so on. So this is how it chooses one alternative after another. So if it is yes or no, based on probability, it moves to the next alternative. So just an example of the decision trees. Albatross used many decision trees for each of this decision. Like mode of work, there are 4 alternatives. Activity selection, there are 2 alternatives, flexible and fixed. Activity with whom, there are 3. Activity duration, there are 3 options. Activity time of the day, 6 options. Trip link, mode for other, activity locations 1, location 2, and so on. So this is how these are examples from a decision tree, how this has been found out. How many in a decision tree, there are some leaves, that is the final options. So there are 23 options of mode of work. There are 116 activity combinations. Then there are activity with whom, there are 57 combinations. So these are the final alternatives that are available. So leaves in a decision trees are the final outcome or alternatives. So activity location 62, 34. So these are the alternatives that they have considered. So this is how we can describe an activity based model. And in case of Albatross, they gives OD trip matrices as output. And we can conclude by saying, we can say that the data required for activity based model has to be collected using travel diary survey. Data should be collected across all household members with information on joint travel and group activities, along with consistent trip arrival and departure time data for each location. So this detailed data is required, otherwise we won't be able to form we cannot predict our probabilities of our trip arrival times or departure times or location if we don't have this kind of data in our data set. Trips need to be combined to tours and sequence of tours into full day activities and travel patterns from the survey itself. Survey sample size at least 6,000 households for a large region. This has been suggested by many researchers. Some researchers have also suggested 2,000 household samples, like in case of Albatross. The researchers say that 2,000 household samples is good enough for a running Albatross model. So we need to have household data. Household data is standard household data like household attributes and person attributes, number of persons in household, household tenure, residential location, number of and age of family members and so on, vehicles owned, number of workers, students. Person attributes like relation to the householder, gender, age, grade in school, hours worked per week, worker status. So this gives me time, how much time he spends in his office and all these things. So student status, transit pass ownership. So these are the different information we get from persons. We also require parcel wise data for land use, maybe for TZ wise or microzone wise. We require network data. Like in a standard transportation model, whichever data we require, we also require data for this particular model, and demographic data for creating synthetic population. So these are the data that is required for developing this activity based model. These are the references you can study. And to conclude, activity based modeling is slowly gaining ground in many countries and urban areas. Key challenges are of course data requirement and lack of expertise. Still, this modeling approach offers several key benefits over traditional models, 4-stage models. For example, tour based representation of travel, continuous prediction as per time of day and total time period, micro level predictions as per any level of socio-economic disaggregation, then predictions considering household level interactions and dependencies, which was not there earlier, and then ability to evaluate different types of policies related to travel and land use. So these are the key benefits, and that's why in the future there is a lot of scope for developing this activity based model also in the Indian context. Thank you.